is the exterior angle theorem. When I say an exterior angle, I mean if you extend one of the sides. So we have these three sides in a triangle, we extend this one. This is an interior angle, this is the exterior angle that's created by that extended side. The two other angles are called the non-adjacent interior angles. They're not adjacent to this exterior angle that we just set up. The exterior angle theorem says that the measure of an exterior angle is equal to the sum of the measure of those two non-adjacent interior angles. So this exterior angle is 100. That adds up to, that equals these two added up. And that should really make sense. If we're extending this line, we know that these three angles, that one, and that one, add up to 180. We also know that extending this line creates a linear pair, so these two have to add up to 180. So this adds up to 180 with this angle, and these two together add up to 180 with that angle, so they have to be the same. So we also want to see this picture on the right, because you can see that there's not just that one exterior angle. We could also extend this line and create another exterior angle there. Actually, we have two exterior angles at each vertex. Any line that you extend, you can extend the other side at that same vertex and create a second exterior angle. They're also going to be the same. You can see that those are vertical angles. Alright, so we're looking for the value of y here. We have the exterior angle, and we have these two angles that are not adjacent to that angle. They're the non-adjacent interior angles, so they have to add up to 146. So 5y plus 3 plus 4y plus 8 equals 146. So 9y plus 11 equals 146. 9y equals 135. I'm subtracting 11 from both sides and then dividing by 9. We get that y is 15. Next one's a little bit trickier. We're given each exterior angle in that triangle. I'm going to relabel these angles. I'm going to call this lowercase a. I'll call this one lowercase b. And I'm going to call this one lowercase c. So eventually I want to find angle BCM, or the one that I just labeled with this lowercase c. First, I want to try to describe each of these angles in terms of variables. So 9x plus 1, that's the exterior angle here, which means that it's these two angles put together. 9x plus 1 equals B and C put together. These two angles put together, those are the non-adjacent interior angles. I'm going to do that same thing with each of them. 10x minus 37 equals the two angles that are not adjacent to it, so it equals A and B put together. And then 5x plus 12 equals its two non-adjacent angles added together, that's A and C. There might be another way to set this up. This is just the way that I thought of. So we know that each of these is now in terms of A, B, and C. If I add all of these together, there's two A's here. So it's kind of like last year when we did systems of equations, where you did elimination and you just put all of these equations together. If I just look at the right side, I have two A's, I have two B's, and I have two C's. I know that A plus B plus C equals 180. Here I see that I have two of each of those. That has to add up to 360. It's 2 times A plus B plus C. I know that A plus B plus C is 180, so that has to be 360. And that's going to give me an equation with just one variable. Now I can add on the left side. I'm just going to combine like terms. Get 24x minus 24 equals a total of 360. All right, I'm going to add the 24 to the other side. Get 24x equals 384. And then we'll divide by 24 on both sides, and I think that's 16. So that's the value of x. We're really looking for this angle C here. I'm going to find this first. I'm going to plug in the x there, 160. That's 16 times 10 minus 37 is 123. So this angle is 123 degrees. That's the rest of the 180. So angle BCA has a measure of 57 degrees. All right, that's exterior angle theorem.